Welcome to The Explainer. Today, we're going to crack the code on how to talk to AIs. We're turning what feels like an art into a science you can actually master. Let's dive in.
So, have you ever asked an AI for something and it gives you a vague, inconsistent, or just plain wrong answer? Yeah, if you've been there, you are not alone. You've stumbled upon this single biggest challenge in using these amazing tools. How do you get them to do what you actually want reliably every single time?
See, here's the core of the problem. Treating these super advanced AIs like you're just having a casual chat, well, it's great for demos. But when you need real, predictable results, that whole approach just falls apart.
And this isn't just a theory. A developer, Manalimran, put it perfectly. They said that whole just ask and hope for the best approach, it worked for demos, sure, but in production, it was a disaster. Responses were all over the place, formats kept changing, and you guessed it, everything downstream just broke. It's a total recipe for failure when reliability really counts.
So how do we fix this? Well, that's what we're here to do. We're going to walk through the prompting problem, how to engineer better prompts, the power of using examples, how to teach an AI to think, and finally, how to get your prompts ready for production. Let's get into it.
All right, so the first big shift we need to make is in how we think about this. It's not about writing longer prompts or getting more poetic. No. The real game changer was realizing we need to write clearer specifications. Think of it less like asking a question and more like drawing up a contract with the AI. And where does that contract start? It starts with defining your success criteria. You have to know exactly what a good output looks like before you even start. You know, it's funny, we complain about bad outputs from the AI, but honestly, most of the time, that's just a symptom of us giving it a poorly defined goal in the first place.
Okay, so a really fantastic way to structure this is something called the four-block layout. It's super simple. Block 1, instructions. Just state exactly what you want the model to do. Block 2, inputs. This is the data, the document, whatever context it needs. Block 3, constraints. This is where you set the rules, what to include, what to exclude, and hey, what to do if you're not sure about something. And finally, Block 4, the output format. Be super specific, like telling it you want JSON or a bulleted list. Breaking it down like this, it just makes it way easier for the AI to get it right. And maybe more importantly, it makes it so much easier for you to figure out what went wrong.
All right, so structure is absolutely key. But let's keep building on this idea. Because just having clear instructions, even in that awesome four-block layout, isn't always enough, especially when the exact format of the output is super critical. And that's where a technique called few-shot prompting comes into play. It's basically the old rule of show, don't just tell. Instead of just trying to describe what you want, you actually show the model a few perfect examples. And this simple trick anchors its behavior way better than any descriptive words ever could. Just look at the difference here. On one side, you have vague adjectives like, be concise and professional. I mean, what does that even mean? Really, it's so subjective. But look at the other side. You give it a clear example. Input is this, and the output should look exactly like this. See, there is zero ambiguity. It provides a rigid template that forces the model to give you a precise, machine-readable format every time. Okay, so with structure and examples, we're getting consistent, well-formatted results. That's huge. But what about for the really complex stuff, the problems that require actual reasoning? For that, we need to go one step further. We actually have to teach the model how to think. The breakthrough here is a technique called chain of thought prompting, and it's shockingly simple. Instead of just asking for the final answer, you just add a little phrase like, think step by step. That's it. This little nudge encourages the model to break down the problem, lay out its reasoning, and basically show its work, just like your math teacher always told you to do. And this example just illustrates the difference perfectly. Look at the standard prompt. You ask the question, and it just jumps to an answer, which happens to be wrong. But with chain of thought, the model says, okay, wait, Roger started with 5 balls. Then he got 2 cans of 3 balls each, so that's 6 balls. 5 plus 6 is 11. It reasons its way to the correct solution. It's night and day.
That one little change in technique, that's often the entire difference between failure and success. Because it's not just about getting the right answer, it's about giving us a window into how the model is actually thinking.
And the data on this is, well, it's just striking. Take a look. On a really tough math benchmark, a huge language model, we're talking the Palm 540B model, it only scored 18% with standard prompting. 18%! But just by adding think step by step, its performance shot up to 57%. It more than tripled its score. That is a massive leap.
Now, here's a really interesting little detail. This ability to reason like this, it's what's called an emergent property. It only really works on the massive models, the ones with about 100 billion parameters or more. If you try this on smaller models, they'll try to create a chain of thought, but the steps they come up with often don't make any logical sense. So size really does matter here.
Okay, so you've built an amazing prompt. It's got the 4-block structure, it's got great examples, you're using chain of thought, you're basically a pro. But how do you make sure it's actually robust enough to use in the real world, in a production system? Well, here's a clever trick. You can build a little pre-flight checklist right into the end of your prompt. You're essentially asking the model to double-check its own work before it gives you the final answer. Does the output match the format? Did it satisfy all the criteria? Are uncertain claims marked? It's a simple self-check that can catch a ton of common errors before they become a problem.
And that brings us to what you should absolutely avoid. We call these anti-patterns. Things like just dumping a long list of keywords and hoping for the best, or having hidden expectations about the format but not actually stating them, or my favorite, dumping a giant wall of text as context without telling the model what's important. And the biggest one of all, failing to test and iterate on your prompts. These are the things that lead to that frustrating, unreliable AI behavior we all want to avoid.
You know, we boil it all down, it comes back to that fundamental shift in mindset. We have to stop treating prompts like a casual chat and start treating them like a well-defined API. Getting a structured, reliable output isn't magic. It doesn't happen by accident. It's an engineering discipline.
And that leads to a really fascinating final question, doesn't it? We've just spent all this time learning how we can get better at engineering prompts for AIs, but what happens when the AI starts engineering its own prompts? Because this isn't science fiction. We're already seeing automated frameworks that can do exactly that. You give it a simple goal in plain English, and the system automatically generates, tests, and optimizes the perfect prompt for the job. It's wild to think about, but the prompt engineer of the future, they might not be writing prompts at all. They might just be guiding the AIs that write them for us.